Hello students, in this video we will study about the class 9 standard physics chapter 8 motion in text questions or blue question answer. So let's begin. Question number 1. An object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. So as we know that the object can have the displacement 0 if it is moved through a distance. Suppose the object is at position A and it is moved to the position B in straight path, and again it returns back to the position A. So we'll find that the initial and final position is same. In this case the object will have the zero displacement. Similarly, in case of the circular path, if the object is moving from point A and returning back to the point A after completing one revolution, then we can say in this case the object will have the zero displacement. Next, a farmer moves along a boundary of square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from its initial position? So here first we need to find number of rounds completed by the farmer. So here we will find that this is the square field and the side of this square is 10 meter. Time taken to complete the one round, it is about 40 seconds. So number of rounds taken for the time 2 minutes 20 seconds. So we can say number of rounds, it is equal to total time divided by the time taken for the one round. So here we can see that number of rounds, it will be total time, it is about 2 minutes 20 seconds. So 2 minutes, it means that 120 second, and 120 plus 20, that is 140 second, divided by total time for one round, it is about 40 second. So we can divide it by 40. So here we can divide it, we will get the 14 divided by 4. So 0 get cancelled. So here it is divided by 4. So dividing it, it will give us the 7 by 2 dividing to the numerator and denominator. 7 by 2, it is a 3.5. So total number of round, it will be 3.5. Now we will find that the actual position of the object after 3.5 round, the number round 1, then another second round, then again third round. After 3 round the object will be at the same position, and then again this half round it will be there, so it will be moved to the point B and B to the C. So you will find that the initial position E and final position is C. So this is the shortest path between A and C. So here we have to find the displacement, and displacement is that it is the shortest path between the 2 points. Now we can see that how much is the distance AC. So we can see here is a triangle ABC, and in triangle ABC we can see that the AB is 10 meter and BC is 10 meter. So using Pythagoras theorem we can write that AC square is equal to AB square plus BC square. So the AC, it will be taking square root on both sides, we can get AB square plus BC squared. So it can be square root of AB square, it is a 10 square, and BC it is also 10 square. So we will get square root of 10 square, it is a 100, and again this 10 square, it is a 100. So we will get 100 plus 100, it is a square root of 200. So we can find the AC, that is equal to square root of 2 multiplied by 100. So the square root of 100 is a 10 multiplied by root 2, that will be the answer. So we can write 10 multiplied by the value of root 2, it is a 1.414, and this multiplying 10 to the 1.414, one decimal point will shift towards right side, it will be 14.14 meter, and this will be the AC, which is nothing but the displacement. So shortest the part displacement D is equal to 14.14 meter. So this will be the answer of this question. So next question, which of the following is true for the displacement? It cannot be 0. So displacement can be zero if the object is moving from one point to another point, and again returning back to the initial position. We can say that here the displacement can be zero. So this statement is false. Now second is that its magnitude is greater than distance traveled by the object. So we can say that the distance is always greater or equal to the displacement. So this means that this is also the false statement. So let's move to the next question. Distinguish between speed and velocity. So as we know that speed is the distance traveled upon time and the velocity is the displacement upon time. It is speed is the scalar quantity and velocity is the vector quantity. So this is what the difference between the speed and velocity. Speed is the distance upon time and velocity is displacement per unit time, and it doesn't have the specific direction to the speed, while it will have the particular direction in velocity. Of course, speed is the scalar quantity and velocity is a vector quantity. So this is what the difference between the speed and velocity. Let's go to the next question. Under what conditions is the magnitude of average velocity of an object is equal to average speed? So we know that when the object is moving in a straight line, that time the average speed and average velocity will be same, because we know the speed is the distance upon time and velocity is the displacement upon time. The distance and displacement will be same if the object is moving in a straight line. So in case of the straight line or straight line motion, the average velocity and average speed, it will be equal. Let's move to the next question. What does odometer of an automobile measures? So in case of the four-wheeler and two-wheeler, there is a odometer, an instrument and a device. We can say it is used to measure the distance traveled by the object, or we can say the distance traveled by the vehicle. So distance traveled by the vehicle is measured by the odometer apparatus device. So this is what the use of odometer. Next question, what does the path of an object look like when it is a uniform motion? So we can say in case of the uniform motion, the path may be curve path, circular path or even zigzag. So uniform motion means that the object covers the equal distance in equal interval of time. So here the speed is constant but direction may change. So it can be the path of the object may be curve path, it can be circular, it can also be straight line or even zigzag. Next, during an experiment, a signal from the spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? The signal travels at the speed of light, that is 3 into 10 to the power 8 meter per second. Here we have to find what is the distance from the spaceship to the ground station, and we know that the speed of the light, it is given 3 into 10 to the power 8 meter per second. So we can say the speed, it is equal to the distance divided by time taken. So distance, it is equal to velocity multiplied by time. So velocity of the light, it is given 3 into 10 to the power 8 and time taken, it is given in minutes. So we have to convert in seconds, so we can multiply with the 5 to the 60 and we can get the multiplication 5 6 3 into 10 to the power 8 multiplied by this 5 into 6, it is a 30 and this 0 will be here. So we can multiply this, we will get 900 into 10 to the power 8 and we can simplify it, this 9 into 10 to the power 2 into 10 to the power 8 and which will give 9 into 10 to the power 2 into 10 to the power 8. So here 2 plus 8, that will be 10 meters. So this will be the answer of the question, that the distance from the spaceship to the ground station, it will be 9 multiplied by 10 to the power 10 meter. So this is the answer. Let's move to the next question. When will you say a body is in uniform acceleration and non-uniform acceleration? So we can say that the body is in uniform acceleration if its velocity changes by equal amounts in equal intervals of time. While in case of the non-uniform acceleration, the velocity changes by unequal amounts in equal intervals of time. So equal amounts of velocity change and in equal interval of time, then it is uniform acceleration. But in case of the non-uniform acceleration, the velocity changes, it will be unequal amounts in equal interval of time. So we can also say that equal interval of times or we can say equal intervals of velocity in unequal intervals of time. It is that there are two things, one is the velocity change and second one is time. If both are equal, then uniform acceleration, and any one of them it is not equal, then it will be the non-uniform acceleration. Next question, of bus decreases its speed from the 80 km per hour to the 60 km per hour in 5 seconds. Find the acceleration of the bus. So as we know that acceleration is the change in velocity divided by time, and here we can say that the speed of the vehicle is decreasing. It means that it is a negative acceleration, and of course negative acceleration is a retardation. So initial speed is 80 km per hour, so we have to convert it into the meter per second. So we have to multiply it 5 by 18, then we will get the answer in meter per second. So we can convert this 400 divided by 18, and here the final velocity it will be the 60 km per hour, and then again I am dividing it with the this 5 by 18, then 60 into 5 by 18, we can simply multiply this 60 into 5, then 300 divided by 18. So this will be the initial and final velocity, and time taken is the 5 seconds. So we can calculate it, the acceleration final velocity, it is the 300 divided by 18 minus initial velocity, it is 400 divided by 18 divided by time, it is 5 seconds. So we can take the numerator common, 1 by 18 into 5, and the numerator 300 minus 400. So we will get this 300 minus 400 is a minus 100 divided by 18 into 5. Just we have to divide it to the term, we will get 5, it will be 20. So minus 20 divided by 18, it will be there. Again we will divide it, it will get by 2 to the numerator and denominator, it will be minus 10 by 9. So acceleration will be, again dividing to the 10 by 9, we get minus 1.1. This much is enough. We can divide the 10 by 9, it is 1.1 meter per second, that is the unit of the acceleration. So this is what the answer of this question, that is minus 1.1 meter per second square. So let's move to the next question. A train starting from a railway station and moving with uniform acceleration attains a speed of 40 km per hour in 10 seconds. Find its acceleration. So railway is a train, it's starting from the railway station, that is initial velocity is 0 meter per second, it's moving with an uniform acceleration which has a speed, the final velocity is 40 km per hour. So we have to convert it in a meter per second, 40 into 5 by 18 meter per second. So we can divide it, this term it will get 20 divided by 9, and 5 to the 10, it is 100 divided by 9 meter per second. Now next is that the time it is given 10 minutes, so time should be in seconds, so 10 multiplied by 60, it is in second. So we can find the acceleration, formula A is equal to V minus U divided by T. The value of final velocity, it is 100 divided by 9 minus initial velocity 0 divided by time, it is a 10 into 60. So 100 divided by 9 into 10 into 60. So this 0 cancel, this 0 get cancelled, we will get the answer 1 divided by 9 into 6, and this will be 1 by 54, and this will be the answer of the question. So we can see here that the value answer, it is a 0.0185. so here we can just simply dividing this, and we will get the answer. It's converted into the meter per second, so 11.11 meter per second, and time it is 10 minutes are there, so 10 into 60, that is 600. So dividing this 11.11 to the 600, we will get the answer 0.0185. So you can simply divide 11.11 to the 600, and this can also be simplified 11.11 into 6 into 10 to the power 2. So for further calculation we can do this. 6, this will come to the numerator, it will 11.11 into 10 to the power minus 2 divided by 6. And if you divide 11.11 to the 6, so we can see 6 ones are 6, and then again 11 minus 6, that will be the 5, then it will become then 1 point decimal point here, then it will be 51. So 6 8s are 48, and 51 minus 48 will be 3, then again it will be 5, and this much we can say 685, it's into 10 to the power minus 2. This minus 2 of course move the decimal point to the left side, it will be minus 0.0185. This will be the acceleration in meter per second square. So next question is that what is the nature of the distance time graph for the uniform and non-uniform acceleration or uniform motion of the object? So we can say the distance time graph for the uniform motion is that is a straight line graph passing through the origin. In case of non-uniform motion, we can say that this path is a curve path for the non-uniform motion. So this is what the slope of the distance time graph, it is giving the uniform motion, it is in straight line, while in case of the non-uniform motion this graph is curved. Next, what can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis? So we can say that the slope of the distance time graph, this on y-axis it is a distance, and on x-axis it is a time, and this graph is parallel to the time axis. It means that the time is increasing but the distance is not increasing. It means that the object is here and it's not changing its position, even the time is passing. Then we can say the object is at rest position, we can say it is a stationary. So object will be at the same position if the time is passing, time is going on, but the distance doesn't change, it is at the same position, so it is a stationary object. Next, what can you say about the motion of an object if its speed time graph is straight line parallel to the time axis? So we can say that the graph in y-axis it is a speed, and on x-axis it is a time, it is given, and it is a parallel to time axis. We can say the speed of object is constant, speed of object is constant. So this is what the speed is not increasing, it is a constant even the time is passing. It means that the object is moving with a constant speed, we can say it is with a constant speed. So when the graph of the speed time graph is a straight line parallel to time axis, the speed of object at every instant of time is just the same. It means that the object is moving with a constant speed. Next, what is the quantity which is measured by the area occupied below the velocity time graph? So we mentioned here the velocity graph, velocity versus time graph, and here we will find that the area under the graph, it is giving us the distance traveled by the object. So here we will say that the area under the velocity time graph, it will gives us the actually distance traveled by the object. Next, a horse starting from the rest moves with a uniform acceleration 0.1 meter per second for 2 minutes, then find the speed acquired and distance traveled. So here we will see that the initial speed is 0 meter per second and the acceleration is 0.1 meter per second square. The time taken is 2 minutes, it means that 1 minute is 60 seconds, so 2 minutes is 120 seconds. We have formula for the velocity, it is the final velocity is equal to initial velocity plus acceleration times multiplied by time. That is the first equation of the motion. So initial speed, we put the value of initial speed is 0, acceleration 0.1, and the time it is 120. So this we will find that 0.1 into 120, it will give us 12 plus 0, that is a 12 meter per second. The speed acquired by the bus, it will be 12 meter. The distance acquired by the object we can also calculate by using the mathematical formula, this equation of the motion, that the second equation, s is equal to ut plus half at squared, and if I find that the initial speed is 0 multiplied by 120, that is time 120, plus 1 by 2 into acceleration 0.1, it is given here, and the time 120. 120 into 120, that will be 1000, this 14,400, and this 2 dividing it will give us 0.1 decimal point is 1440 divided by 2, that is 720. So this you can simplify if you have some doubt. 0.1, it means that it is 1 divided by 2. 0.1 means 10 to the power minus 1, and 1000 14,400 will be there. So you can further simplify 1 by 2 into 10 to the power minus 1, it comes to the denominator, it will be 1 by 10 to the power plus 1 into 14,400. So you can cancel this 0, we will get 1440 divided by 2. Dividing this 1440, you will get 720 meters. So this is what the actually distance traveled by the bus, it is a 720 meters. Next question is that a train is traveling at a speed of 90 km per hour and brakes applied so as to produce the uniform acceleration minus 0.5 meter per second. Find how far the train will go before it brought to the rest. So we can say that the final velocity is 0 and the initial speed is 90 km per hour. The brake is applied, and we have to find the how much distance it is going there. So S is equal to ut plus 1/2 at square. We just have to put the value and we can get the value of S, that is the distance traveled when the brake is applied. So the negative acceleration is there, the retardation is there. Initial speed, it is 90 km per hour. We have to convert this initial speed 90 km per hour into the meter per second. So 90 multiplied by 5 by 18, so 5, 18 divided by 90, so it will be 5 to 5, 25 meter per second. So we have to put the value 25 into the value of time. It is not given in this question, so the time is not given, so we cannot use this formula. We have to use the formula v square is equal to u square plus 2as. So here the v square minus u square is equal to 2as. So the s, it will be v square minus u square divided by 2a. So we just put the value of this final velocity, it will be 0 because the train or the object, it is a train, it is a come to the rest. So 0 square minus initial speed, that is a 25 square divided by 2 into acceleration, it is given minus 0.5, isn't it? So this will be the S is equal to this answer of this question minus 25 square 625 and 2 into minus, it will be there minus 0.5, it is a 1 by 2, minus will become plus, it is 625 meters with the answer of the question. So here we can see that this is the answer of the question. Just put the value into the third equation of motion and you will find the value of S. Now let's move to the next question. A trolley while going down inclined plane has acceleration 2 cm per second square. What will be its velocity 3 seconds after the starts? After 3 seconds we have to find, and it is going inclined, if that initial speed it is a 0 meter per second. We will find it is going inclined and acceleration it is given centimeter per second square, and what is velocity after 3 seconds. So time it is given 3 seconds, so we have to find what is final velocity. We can use v is equal to u plus at formula, and what is its final velocity. So v is equal to initials, it's a 0, acceleration given 2, and time it is given 3 seconds. So v is equal to 2 into 3, 6 centimeter per second. This will be the velocity, 6 centimeter per second. That is after 3 seconds the velocity will be 6 centimeter per second. So this was the very easy question. Next question. A racing car has uniform acceleration 4 meter per second square. What distance will it cover in 10 seconds after the start? So here also we have to find the distance traveled, so we can get the third equation, v square minus u square is equal to 2as, but here the time it is given, so we have to use the equation s is equal to ut plus 1 half at squared. Here the initial velocity is 0 meter per second and the acceleration is given and the time also given, so s is equal to 0 multiplied by t plus 1 by 2. Acceleration it is of 4 multiplied by time it is given 10 into 10 square it is that, so we can multiply 10 to the 10 and this will cancel, it will become 2. You can say s is equal to 0 into t, 0 plus 100, 10 into 10 100 into 2 it is a 200, so 0 plus 200 will give us the 200 meter. So this is the answer of this question. Here is the solution. Let's move to the next question. A stone thrown in vertically upward direction with velocity 5 meter per second. The acceleration of the stone during its motion is 10 meter per second in downward direction. What will the height attained by the stone and how much time it will take to reach there? So we can see that when stone is thrown vertically upwards, the velocity of the stone goes on increasing because of the force gravity of the earth acting on it in the downward direction. So the acceleration produced in stone is negative and hence it is to be written with the minus, that is minus 10 meter per second square. So initial speed it is given or velocity is given u 5 meter per second. Final velocity will be 0. In acceleration it is in upward direction, so it will be minus 10 meter per second square. So distance traveled can be find out, v square is equal to u square plus twice s. V's final velocity is 0, so 0 square is equal to initial speed it is a 5, so 5 square plus 2 times acceleration is given minus 10. S is the distance traveled that we have to calculate. So 5 square is a 25 and 10 into 2 that is a 20, so 20 times s, minus sign will be here. Then we can see that this 0 is equal to 20 minus 20 s 12 25. It is moving to the minus side, so minus 25 is equal to minus 20 s, so minus minus will become plus, so s is equal to 25 divided by 20 and dividing it will to the 5, it will be 5 5 25, so 5 by 4 we divide it, we will get 1.25 meter. So this is the answer of this question. Let's move to the next question. Here the next question, in that question is again asked the how much time will it take to reach there. So to find the time taken to reach there, we can use the first equation, v is equal to u plus at, and here the final velocity is 0, initial velocity is 5 and the acceleration is minus 10, so 5 into minus 10 minus 5, 5 will move to the left side, it will become minus 5 is equal to minus 10t. So t will be minus 5 divided by minus 10, that will be 5 by 10 and 5 by 10 it will be 0.5 second. So time taken by the stone to reach at the top will be about 0.5 second. So these are the all questions from this chapter. Basically these are the blue questions and we'll see you in next video. Thank you.